Professor. I'd now like to discuss the Sprite class and the Ranger class. The Ranger class we talked about in the animation video, but because the Ranger class extends Sprite, we'll mention it here too. And here is the Sprite class. It extends Rect, and more on that later. Here's the class attributes X and Y. We made an object of screen, named screen, that of dimension, name screen, that we can use to now get with a dot operator, get the width. And the reason for this was to try and make a dynamically sized sprite. So given a resolution, if you were playing the game on a screen that had a lower resolution, you would have a sprite that wasn't too small and too big. It would be dynamically sized. That was the idea. Before we settled, my group partner and I settled on the dimensions being 1920 by 1080 for the game. This is 1920 by 1080. My resolution is larger, so it doesn't fill the whole screen. But we settled on that because that's a standard high definition resolution, and I know, Professor, that you have a monitor at least, if not more, bigger than this. So, and that's why we chose that. So here is a instance of animation. It's an array of animations called animation. It's declared but not initialized. And here are the final ints, which are easier to remember by their names than they are by their numbers. So for coding purposes, we use these booleans, and some of them static, because this game is very driven by the state of the sprite. So right now the game started. I just started the game, and the sprite is it playing? No. Are they playing? No, they're not playing. It's false. Their motion is right, so that when we do press enter to play the new game, they will spawn facing right. But they cannot play right now because they're not playing. They're not, and that's why if I press the up, down arrow keys and firing button, I can't do anything. But once I start, now I start in the right spot. I haven't shot any arrows. I'm facing right. So that's what these static booleans are here for. Easier to refer to than getting a bunch of methods and getters and setters. I remember a video you recommended, Professor. It was the man made a parody of overinflating Java programs when you don't need to. So I took that to heart, and I do enjoy using static variables. I'm not sure if this code is all formatted all that great. I know that Nicholas has a lot more experience with Java, but I myself definitely have much to learn. So if this is disorganized, you can blame me, Professor. Alright, so the final thing I'd like to mention about our variables up top is, our class variables, is the motion. So easier to remember the names, but we also want to not only set the motion for the character when he's born, but it's very easy to refer to say, hey, I need to know the last motion or direction the character was facing. Oh, let's just find out what's in motion, and that'll tell us. This method I will allow Nick to explain, but moving on. So we have the revive. So in a possible version of this game, we could, after dying, we could be revived by an item in our inventory or some other factor, or simply when the character had to be drawn in a new location. Let's say he died off somewhere else and he was respawning near his cabin. Then that would be, we wouldn't want him to respawn flat like a pancake. We would want him to respawn normally, standing up. He's alive, and we want to set these. So something about my knowledge of Java, I found this interesting, but seems that animation at a given index has its own current variable to play with. By that I mean, so first of all, why we need to reset it to 0. Because if I die facing left without that comment, without that code, if I die facing left the first time around, it'll play like normal from 0 to 9. Current will play from 0 to 9. And our animation with our delay of 10 will give me all those frames a bunch of times, enough times for it to render and the human eye to catch and see, and a fluid motion. But once I died again, I would just go back to a flat pancake. But one thing I found interesting is that no matter what happens to the current current, and I'd like to know more about this, I'll do some research on my own, but what I found interesting is that current for die facing right is, if we reset it to 0 and we die facing left, it doesn't matter. Anyway, so that's that. That's why we need that. And here's the sprite method, which is so this sprite class extends to rect, and the constructor for sprite calls the super class's constructor, and the super class is called rect, and the super class's constructor is called rect. So it puts when you create a sprite, it puts the same x and y, the same for both. And the idea is that, as we discussed in our class, in our course, for video game programming, if you want to have collision detection, nobody wants to play a video game of a rectangle walking around. They want to see sprites. So that's why we have the rectangle that's not drawn, but it's there, and to detect the collisions, and that's why that's there. So that's why that extends to, this class extends to rect, and this is super is here. And then animation, now we are taking that animation that was declared, and now we're initializing it to a new instance of animation of pose.length, and pose.length is 13. Oops, is 13. And then we are using a for loop to get those animations. And here is the move up method, which looks a lot like our method that we discussed in the course. Just some extra assignments going on inside of them. And then the py is changing, not just by delta, but by delta plus our speed. So it would be plus 0, plus 0, plus 0, but when you hold the shift key, suddenly you're moving by a greater amount of pixels. So that's that. And then down is the same thing, and these extra assignments are going on because for strafing, potentially if we wanted to implement strafing in the game, we would want to know if we were firing. We want to know if we're moving, because if we're moving, we don't want to be able to. We could have some if conditionals here. If we're moving and if we're firing, then we don't want to be able to move by such a great amount, even if we hold shift. We want to be able to simulate that strafing, where a human being and strafing in a game means when you're aiming your bow and arrow, and you move left and right, you're still facing. You would still be facing right when you're you would move at a slow pace too. So that would be like real life, and that's what the logic that we wanted to do for the game. We didn't get to in this version of the game as it is now. But that would largely depend on, as I think I've mentioned, that if you wanted to do that, then our firing logic would change. Instead of pressing F to fire, it would be press F and hold it down, and the power meter would fill. And then once it filled up to the top is ideally when you want to release. And when you released F, then the arrow would fly. And the power meter would degrade after a while, because holding that posture and bow reeled all the way to the back is something you can only do for a finite amount of time. There's tension. So that was why these exist. And then the difference here is Nick added a condition where you can only move right if your position is 149 or below, because you should not be able to move to the right more, because if you move to the right more, it would make the game easier to score some points and hit the target. So that's the invisible wall, how it's implemented, and there it is. And now we can go down to draw bow right. We only currently have draw bow right, no draw bow left or up and down. But there's some logic here, where assignments, excuse me. So is firing is true, same thing, same logic and same reasoning behind it for a later version of this game, potentially. And then we also make sure the motion is changed, and the animation starts at 5 instead of starting at 0, because if we started at 0, oops, we finished the game. Let's just close it. If we started at 0, which we'll show here, then when he fires the bow, the bow just flies, and he's not even done. You see, he won't even be done drawing the bow. So how does the arrow fly? So the workaround for that was just to start it at 5, and we never actually use 1 through 4 in this current version of the game. But it looks a lot better. Looks like you really did shoot the bow, the arrow. So that's why that's there. And then this is a die method here. So dying requires you to, your boolean is alive to change to false, and then you're going to be drawn your position wise off screen, all the way up here. 10,000 is very high, very way off the screen. And that's the logic behind that. And then here is the draw method from the sprite class, which checks for conditionals. If you're alive and if you're firing, then you better be firing using the shoot animation for the recent motion. And the logic here was your most recent motion dictated which direction you were going to fire in the shoot draw bow right, in the shoot animation class, method. Shoot animation here. So depending on which direction you were facing is which image you were going to return. And then here is the here's the rest of this. So if you're moving, then your motion, so when you're walking up and down, you want to be able to walk up and down like this. So that's for the motion. Down, you're getting current image down with a delay 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 8, 7, 7, and so on. Very quickly, much quicker than I can speak. And then here, if you're alive, if you're not firing and you're not moving, you're standing still. So your character is going to stand still. And if he's standing still, his motion reel, the animation, is going to be the idle animation in a given direction. So here's tapping his foot rightward. He's tapping his he's tapping his left foot here. He's tapping his right foot here, and he's blinking here. So that's their idle. Else the final direction is up, and we don't have anything for up. So that's why that one is not get current image, but get still image. So it's constantly returning 0 of upward. 0, 0, 0, 0, 0, 0 instead of this. But imagine it in one place. Imagine this in one place, but standing still. You'd be walking in place. We would be moonwalking if you were moving backwards. But that's not what's going on. That's a still image. And here we have the motions to determine which way to die. And I think I covered this already. But if you're down or right, you want to die facing right. And down or right, down or right, die facing right, fall backwards leftward. Otherwise, guess what? There's only one other way you can die, because we only have one other way. And that is the Sprite class. Thank you, Professor, for your time.